Year 12, higher level biology, mid-course exam. This is paper 1A, and we're into the third section. We're going to be doing questions 21 to 30 in paper 1A. And we begin with this question here about the gas exchange surfaces of the lungs of mammals. Let's just look at those. Gas diffuses across moist surfaces. That certainly does. Concentration gradients are maintained by ventilation. Certainly are. Water is lost. This is the case. When we breathe out air that contains variable but significant amounts of water vapor, so that's true as well. So I want 1, 2 and 3, which is option D. 21D is my answer. We come to question 22. This is to do with spirometry during normal breathing, and we can see from the graph with the cycling here that the exchange in tidal volume is about half a litre. We've got time down here as well. It's asking, excuse me, what are the tidal volume and ventilation rate? So tidal volume and ventilation rate. Tidal volume we have already, but to get the ventilation rate, what we can do is count the number of breaths in per unit time. And so we have 1, 2 and 3 in 12 seconds. So if I have 3 in 12 seconds, but I'm interested in the minute, then what I need to do is multiply that by 5, and that will give me 15 breaths per minute. So that will be like this. So let's look at the options that are being offered in the here. So neither of those, because I need this value here, and then we have 15 here. So we are on 22D. What occurs during inspiration? So quickly we think about the inspiration process with the flattening of the diaphragm and the movement upwards and outwards of the intercostal muscles, reducing the pressure in the thorax. So let's look for options. Intercostal muscles, internal intercostal muscles contract, increasing the pressure in the thorax. They might do, but that's not inspiration. Internal intercostal muscles contract, decreasing the pressure. That is not their function. External intercostal muscles contract, decreasing the pressure in the thorax. This is a distinct possibility. External intercostal muscles contract, increasing the pressure. That is incorrect. We are opting for 23C. Into question 24. A plant is allowed to photosynthesize in the atmosphere containing radioactive carbon-14. So the carbon dioxide will be in the form of carbon-14, and through photosynthesis it will end up as C6H12O6, and the carbon would be on the sugar molecule as a simple example. And it's asking where in this plant stem would the radioactive sugar be found? Well, sugar is transported in solution in the sap, and the sap is in the phloem. So that's our knowledge. Now we need to select the correct answer. A is the epidermis, or indeed parenchyma tissue, so it's not that one. This mass of tissue here, that is the phloem. So this is our answer, 24B. That's actually xylem. And if you look lower down, this one here is actually the parenchyma tissue of the pith. So that doesn't fit. So 24B. 25. Which characteristic of the subclavian vein distinguishes it from the subclavian artery? The subclavian is a distraction. The question really is, which characteristic of the vein distinguishes it from the artery? And large lumen does seem to fit the bill straight away, so it looks like we're going to go for 25A. Quick check, absence of valves, certainly not. Veins have valves. Pores doesn't come into the discussion, and the layers of muscle are not a distinguishing feature. So 25A. What property of arteries? What is a property of arteries? Arteries have elastic walls. Well, already that works. Let's just be careful. Arteries have valves. No, they do not. All arteries carry oxygenated blood. That is not true. Consider the pulmonary artery. Arteries receive blood from the atria. They don't. They receive it from the ventricles. So we are indeed going to go for 26A. What's the advantage of capillary walls being 1 cell thick in the systemic circulation? They've told us this for a reason, and to distinguish it from the lung tissue. So if we have the heart here, the arteries taking blood to the tissues of the body, that's the systemic circulation. If we were dealing with going to the lung, that would be pulmonary circulation. This is significant. To allow carbon dioxide to diffuse into tissues, which it does not. To allow oxygen, so the events are taking place here. To allow oxygen to diffuse out of the tissues, well, they go the opposite direction, so not that one. To allow glucose to diffuse into tissues, that would work. Let's just check. To allow urea to diffuse into tissues, urea is the waste from the breakdown of amino acids, so that is the opposite, so we would go for 27C. 28. The diagram shows where the exchange of substances between blood and tissue fluid occurs in the capillary bed. Let's just move this up so we can more clearly see the question. What explains the movement of solutes from blood to tissue fluid at region X, which is here? Now notice that the blood flow is this way, and therefore this is the artery end, and therefore the blood here is under pressure, whereas at this end the blood would be under lower pressure. Let's check out the answers. Blood plasma has a higher concentration of solutes than tissue fluid. Let's hold on to that one. Does that explain the movement? No, it doesn't. Tissue fluid has more negative water potential than blood plasma. So tissue fluid with the more negative water potential than blood plasma, in fact, they are the same, since tissue fluid is derived from blood plasma, so that's not going to work for us. Hydrostatic pressure is higher in blood than in tissue fluid. Well, at this region, that is the case, and that is the explanation for the formation of tissue fluid. So option C seems to be a possibility at this point. The permeability of the capillary walls is highest at region X. No, the permeability is the same across the entire tissue, so we're left to opt for C. Question 29. The diagram shows changes in pressure in the left atrium, left ventricle, and aorta. So that one there is the aorta, this one is the left ventricle, and this is the left atrium. At what point during the cycle does the atrioventricular valve close? Now, for this to be the case, the pressure, I'll just use letter P, pressure in the ventricle has to be greater than the pressure in the atrium. So those are the conditions that we need to have, and the solid line here, that needs to be above this one here. So let's go through the options A, B, C, D on the graph. So at point A, we actually do have left atrium pressure here is greater than left ventricle. I beg your pardon, left ventricle pressure is higher than left atrium, and therefore that would bring about the closure of the atrioventricular valve. So it looks like we're going with A. B is relating to the semilunar valve. C also is a semilunar valve occasion, and D is actually where we have the opening of the atrioventricular valve. So we have to retain A as our best choice, our best fitting choice, 29A. And the last question, what blood does the right semilunar valve, what blood flow rather, does the right semilunar valve prevent? So I'm thinking of a simple diagram of the heart. I'm thinking of the right semilunar valve is in the pulmonary artery, is coming out of the pulmonary, from the right ventricle. So it's preventing a backflow from the pulmonary artery into the right ventricle. Let's look for that one. Not this one. Blood flowing from the pulmonary artery to the right ventricle when it's relaxing. That's correct. So I'm going to choose C. That's the conditions that I stated up here. The backflow, as the heart relaxed, there's a backflow. The semilunar valve closes to prevent the refilling of the right ventricle. 30C. We're finished the multiple choice paper.